Okay, so this video is on 11.1, Intro to Quadratic Graphs. All right, so there's a lot of information on this page. We're going to go through each piece here one at a time. So we're going to start out with some definitions. So over here we have a picture of a quadratic graph. Remember, quadratic graph means that there's an x squared. It also is in the shape of what's called a parabola. Okay, parabola is just that U shape, which is what it's called. So a parabola is a name of the shape of a quadratic function. Okay, so that's just the name for this. Okay, the vertex is the point on the parabola where the function changes from increasing to decreasing or from decreasing to increasing. So if it goes from increasing to decreasing, remember increasing is going uphill to downhill. So if it's going from increasing to decreasing, it looks like that, and that would be, that point up there would be a max. And if it's decreasing to increasing, it would be like that, and that point right there would be a min. So that point that is right there in the center is called the vertex. Because it goes from increasing to decreasing or decreasing to increasing. When it is a mountain, it's called a max, and when it's a min, it's called, or a valley, it's called a min. Okay, but it's always going to be that point that's called the vertex. Okay, concavity. Concavity means that if a graph has a maximum and the sides are pointing down, it is concave down. So concave down looks like this. It's like a bowl turned upside down. Okay, when a graph has a minimum and it is therefore pointing up, we say that it is concave up. So a bowl sitting regularly on the table would be called concave up. Okay, so it's the ends here that are going up for concave up, and it's the ends here that are going down for concave down. So this blue parabola, quadratic here, is concave up because the ends are going up. Okay. So on here, here's our vertex, and the vertex is at the bottom. It's lower than all the points around it. It goes from decreasing to increasing. So that vertex in this case would be a relative minimum. Okay. So an axis of symmetry, the line through the graph over which you could perfectly fold the parabola in half. It is a vertical line through the vertex. The equation of this line is where x is equal to the x-coordinate of the vertex. So if the vertex is at 1, -4, the axis of symmetry is at x equals 1. Okay, so that's just here. Our vertex is at 1, -4, and this orange line is the axis of symmetry. So that's going to be the axis of symmetry is at x equals 1. Right, that's where x equals 1. Okay, x-intercepts are the points where the graph crosses the x-axis. Right, we've learned that before. So here's x-intercept, and here's an x-intercept. Okay, so there's one at -1, and there's one at 3. These points are also called solutions, zeros, or roots, depending on the circumstance. Okay, so just different names for the same thing. X-intercepts, solutions, zeros, or roots. Okay, the y-intercepts are the points where the graph crosses the y-axis. So on this graph, right here, it's crossing at y equals -3. Okay. Now, we have learned and looked at quadratics in some different forms. One form is called standard form. Standard form looks like y equals ax squared plus bx plus c. So we used this a lot last unit. We wanted our functions to be in standard form a lot, especially if we were going to factor them, or if we were going to use a quadratic formula. The other form is called vertex form. And when we were doing transformation, this is the form we looked at. We have a times x minus h squared plus k. Okay, remember this h right here would be how it moved right or left, depending on what number h is. The k out here tells us how it moves up or down, depending on what k is equal to. And a could stretch or compress our function, depending on what a is equal to. So this next section is just simply determine which form these functions are in. Are they in vertex form or are they in standard form? Now, if they have parentheses in them, you know automatically they're in vertex form. So number 1, because it has these parentheses here, so A would be like 4, H would be like 3, and K would be 1. So this one is in vertex form. Okay, the second one we have in standard form. 2 is A, -3 is B, 7 is C. So this one would be in standard form. Okay, number 3 is also in standard form. And number 4 is in vertex form. Okay, so just determining which form they're in. In vertex form, so that's this form here, HK is where the vertex is located. Okay, so number 1 here, so remember your transformations, right? This +3 on the inside would make my function move left 3, and this +1 on the outside would make it go up 1. So think about your graph. If it goes left 3 and up 1, that's where it's moving that vertex to. Okay, so that is where the vertex is located. It's located at HK. So at -3, 1. Now, notice here that H is a +3, but we put the vertex at -3. That's because if we go up to here to the general part, the general form of the equation, there is already a minus in the middle, right? So that's part of the equation. So if I have x minus -3 squared, that's the same as x plus 3 squared. So that's why our 3 is negative here, okay? But if that confuses you, just think about the transformations when you're looking at these. Left 3 would be a -3, right? So the vertex on number 4, since -2 on the inside would go right 2, and -8 would go down 8, our vertex would be down here at 2, -8. So you can draw the picture, you can just look at the equation and change the sign of the one on the inside, and the one on the outside stays the same. Okay, that's where the vertex is. So we're really just talking about transformation, so this is just a reminder of that. If A is negative, that's the number out front, it would flip the parabola upside down. Okay, H moves right or left, it's always the opposite sign that it is in the equation. And K moves up or down, stays the same sign. Okay, that's just the transformations. Okay, so for each graph or equation, identify the following characteristics. Okay, so for each, for this quadratic, the vertex is right there. So we just want to say where the coordinates of that vertex are. So that would be at 2, 1. Okay, and then is that vertex a maximum or is it a minimum? Because this one has been flipped upside down and that vertex is the highest point around all the others, that's going to be a max point. Okay, the concavity, the ends are heading down, like the upside down bowl, that is concave down. Okay, the axis of symmetry, remember that is that line that cuts it evenly and symmetrically in half. So it would be this line right here, which is at x equals 2. Okay, the zeros or x-intercepts are the places where it crosses the x-axis. So I have one at x equals -1, one at x equals 3. You could also list the coordinates, right, which would be -1, 0, and 3, 0. Either one, it works. The y-intercept is where it crosses the y-axis, so this one would be crossing at y equals -3. Okay, again, you could put the coordinates of 0, -3. So either one, you don't have to do both. Okay, next one. this one we are going to have to first sketch ourselves. We're going to use our transformations. So this +3 on the inside tells me it goes left 3, and the -6 means goes down 6. So there's my vertex. The -5, remember those are two separate transformations. The negative flips it upside down. The 5 vertically stretches it, so it's just going to be kind of skinnier. Think of a rubber band that's been stretched. So it looks something like this, okay? So the vertex here, I can either just look at my graph of where it is, -3, -6, or I can use the function. I can look at it, the +3 on the inside would go left 3, the -6 on the outside goes down 3. So there's the vertex. The maximum is the vertex, the vertex is a maximum because it's higher than all the points around it. The concavity, again, those ends are pointing down, so that's concave down. And the axis of symmetry is this line that cuts it in half symmetrically, and it's at x equals -3. Okay. Let's try one more here. So our vertex would be right 4 and up 3. So it's at 4, 3. It's a minimum because this time it's going to open upward. There's no negative to flip it. So it's that vertex is lower than all the points around it. It concaves up because the ends are pointing up. And the axis of symmetry is just the x value of the vertex. It's at x equals 4. Okay, guys, so that's about it today. So go ahead and give the assignment a try, and I hope you have a great day.